Hey y'all, Data Guy here. So today, what I got for you is a little tutorial on how you can create your own custom sensor just from the sensor decorator. So this allows you to basically just write a Python function that you can use as your sensor, which allows you to put any logic you want in it. So in this, we're going to be going a little bit ridiculous and checking for a picture of a sheep. So if you're into crypto, sheep, but really just nice little meme to just show, hey, I can create a sensor based on a picture appearing in a certain location. You can create a sensor based on a data set in a certain location. You could create a sensor every time a data set is updated. Really, the opportunities are limitless. And the task sensor decorator makes this a lot easier where instead of needing to, extend a sensor class and write your own operator, now you can just write a Python function that contains your sensor logic and then add the add task sensor decorator to just turn it into a sensor. So it really cuts down a lot of that boilerplate code you'd have to write before, and really just the complexity of designing your own sensor, which has historically been pretty difficult. So not a lot of people actually do it. So just to kind of set the stage, the only things you're really going to need to import here are just the DAG and task decorators. The airflow sensor based poke return value, we'll be extending that in this. So if you want to include that for your sensor, you can do it. If you want to do a poke return value, but as I said, doesn't need to be the way you actually design your sensor. You can take this similar format and bring your own logic into it. So this is really just kind of a general case study on how custom sensors are built. But please feel free to take this and do your own sensor with it. Have fun. That's what Airflow is all about, having fun. So after we've got our libraries imported, just create a basic DAG using the DAG decorator, just best practices. Give yourself a start date, no schedule if you don't want one. Give it a sensor tag if you want, and set catch up to false. And now we can start designing our first sensor task. And here we have the sensor declaration. So to use the at task sensor declaration, basically you're going to set a poke interval, timeout. You can look up all the different values that you can put in here, but mainly you're just going to need poke interval, timeout, and the mode of rescheduling, so that if it fails, then it'll reschedule to try this again in X amount of time, whatever your back off is. And then for the actual sensor definition, what we'll have here is we're going to check, hey, is the Shiba Inu picture available? So you can see what we're doing here is within the body of the sensor, we're requesting this Shiba Inu API that is supposed to return us a Shiba Inu picture. And so what we're doing here is pinging that API, giving us a request, and then printing the status code of that request. So if we get a 200, then we know we're all good. We know we got the picture and everything works smoothly. So if that's true, then we're going to take that response, put it into a JSON file, and then return it. So because this is a poke return value sensor, it needs to actually return a value at the end of the function. If you're using a different type of sensor, it doesn't necessarily have to do this. So this is specific to the poke return value sensor. And you can see is done. So condition equals met, and the XCOM value is the operation return value. So this is going to allow us to take the value that we just created, the 200 response, and the Shiba Inu picture, and store it in this XCOM value. Then if this fails and it doesn't return us a 200, we want to set that condition met to false, so that we're going to tell ourselves within our DAG code saying, hey, Shiba Inu picture isn't available, and give ourselves a status code printed out within the log as well, just for additional visibility into, hey, what actually went wrong here? Maybe we just couldn't connect, maybe the internet was down, something like that. And so now that we've got our task sensor, let's write another task that'll actually take this and print out a picture. So our next function is just a standard task, just a standard Python task, print Shiba picture URL. So this is the URL that'll take us to our super cute Shiba Inu picture. And you might be wondering, well, how is that URL getting passed? Where is it coming from? That is actually coming from this poke return value. So this XCOM value is the RJSON, so the URL that's giving us the Shiba Inu picture. So the way we're actually going to be passing it is through the TaskFlow API. So with the TaskFlow API, instead of needing to only pass things through XCOMs, you can actually design your tasks kind of just like standard Python functions, or you can have a nesting function. So what we're going to do for the actual DAG declaration is write it like this. So print Sheeb picture URL takes whatever the return value is from this check Sheeb availability and then passes it as the URL into this function. So this is just another great example of Taskflow API making passing values just so much easier than it used to be within Airflow, to the point where it almost becomes trivial. But you do have to get used to the more Python-esque way of actually defining that relationship. And finally, at the bottom, we're just going to declare the DAG, sensor decorator, so it actually runs. And let's go over to the Airflow UI to just take a look at what this looks like. So now that we're in the Airflow UI, let's go check out the sensor decorator. So the flow we just created, took the liberty of running it ahead of time so that here we can look at the Sheeb availability. So you can see within the logs, giving us that 200 info. I know it's super tiny on the screen, but basically it's giving us the information we needed, that we were able to retrieve the Shiba Inu picture. Then when we go to the URL that is returned here, if everything goes right, and this is the first time I'm trying it, no faking, we should see the Shiba Inu picture here. And boom, hurrah. We got a custom sensor built that checks for the availability of a Shiba Inu picture, and then prints us the URL that takes us to that picture. So fun, silly example, but a really powerful tool for designing your own custom sensors in production. So I hope you learned something and have a good one. Peace.